By following the steps in this video, you can apply statistical method to your data in a structured and systematic way, helping you to draw meaningful conclusions and communicate your findings effectively. Statistical method of analysis explained. Step 1. Gather and code data for analysis. This video provides some general guidance on how to gather and code data for analysis. Here are some key points. Point 1. Determine what data you need to collect. Before you start collecting data, you need to determine what information you need to answer your research questions. This may involve developing a data collection plan. Point 2. Choose a data collection method. There are many different methods for collecting data, including surveys, interviews, observations, and experiments. Choose a method that is appropriate for your research question and the type of data you need to collect. Point 3. Develop a coding scheme. A coding scheme is a system for categorizing and organizing data. This may involve developing a set of codes or categories that capture the key theme or concept in your data. Point 4. Code your data. Once you have collected your data, you need to code it according to your coding scheme. This may involve manually entering data into a spreadsheet or database, or using software to automate the coding process. Point 5. Check your data for accuracy. It's important to check your data for errors or inconsistencies before you start analyzing it. This may involve reviewing your data for missing values, outliers, or other issues. Point 6. Store your data in an appropriate format. Before you can analyze your data, you need to store it in a format that is appropriate for your analysis. This may involve converting your data into a specific file format or structure. These are just some general guidelines for gathering and coding data for analysis. The specific step you need to take will depend on your research question, data collection method, and analysis plan. Step 2. Determine the type of data. Basically, data can be classified as categorical data or numerical data, but we'll take a look at categorical data and numerical data respectively. Categorical data are data that classify or categorize some attributes. They may be coded as numbers, but the numbers have no real meaning. They are just labels. Categorical data can be further classified into two types, which are nominal data and ordinal data. Nominal data are data that have no default or natural order. Examples of nominal data include town of residence, color of car, and gender, which may be either male or female. Whereas ordinal data are data that can be put in order, but don't have a numerical meaning beyond that order. Examples of ordinal data include questionnaire responses, coded as 1 to mean strongly disagree, 2 to mean disagree, 3 to mean indifferent, 4 to mean agree, 5 to mean strongly agree, and level of pain felt in a joint rated on a scale from 0 to mean comfortable to 10 to mean extremely painful. We also take a look on the meaning and definition of numerical data. Numerical data are data that are measured on a numerical scale. They can be further classified into two types, which are interval data and ratio data. Interval data are numerical data where the distances between numbers have meaning, but the zero have no real meaning. Examples of interval data include temperature measured in Celsius or Fahrenheit, whereas ratio data are numerical data where the distances between data and the 0 point have real meaning. Examples of ratio data include height, weight, salary, and age. With that, we move to step 3. Conduct descriptive analysis. If your data is classified under categorical data, the next step is to conduct a chi-square test. Interpret your result and draw conclusions. Chi-square test is a non-parametric test. Also, tests that do not depend on many assumptions about the underlying distribution of data are called non-parametric tests. These include the Wilkinson rank sum test, the Spearman's rank correlation coefficient. Also note that the chi-square test for independence can be used in situations where you have two categorical variables. It works with simplest form data such as gender or country, or data that has been placed in categories such as age group. If your data is classified under numerical data, the next step is to conduct descriptive analysis such as creating box plots or other graphs to visualize the data. This will help you identify outliers or other issues. Also note that questionnaire-derived data are likely to be non-parametric. Some common descriptive analysis methods include 1. Measures of central tendency. Measures of central tendency, which describe the center of a data set and include the mean, the median, and mode. They help understand the typical or average value of a variable. 2. Measures of variability. Measures of variability describe the spread of a data set and include the range, variance, and standard deviation. They help understand how much variation there is in your data. 3. Graphs. Graphs can be used to visualize your data and include histogram, box plots, scatter plots, and bar charts. They can help you identify patterns or trends in your data. These are just a few examples of the descriptive analysis method that can be used to analyze data. The specific method you use will depend on the type of data you have and the research question you are trying to answer. With that, we move to step 4. Check your data for normality. The next step after conducting descriptive analysis is to check your data for normality. This will help determine whether parametric or non-parametric methods are appropriate for your analysis. We'll also review methods to check for normality of data. Includes one, we have the histogram. The histogram is a graph that shows the distribution of a variable. If the histogram is bell-shaped and symmetrical, the data may be normally distributed. 2, we have the normal probability plot. The normal probability plot is a graph that compares the distribution of a variable to a normal distribution. If the points on the graph fall close to a straight line, the data may be normally distributed. Next is step 5. Determine which type of statistical analysis to use. The next step after checking for normality of data is to determine which type of statistical analysis to use. If your data are normally distributed, you should use parametric tests such as the t-test, analysis of variance, and linear regression. If your data are not normally distributed, you should use non-parametric tests such as the Way-Coulson-Ransom test and the Kruskal-Wallis test. With that, we move to step 6. Step 6 says conduct inferential analysis. Once you have determined the appropriate type of analysis for your data, the next step is to conduct the analysis. This involves importing your data, selecting the appropriate analysis, specifying the variable you want to analyze, and interpreting the results. We'll take a look at how to conduct inferential analysis. One, determine the appropriate statistical test. One, we should determine the appropriate statistical test based on the research question and the type of data you have collected. This involves considering factors such as the level of measurement of your variables, whether your data are paired or unpaired, and whether your data meet the assumptions of parametric tests. 2. Import your data. Import your data and select the appropriate analysis for a wide range of statistical tests, including t-test, analysis of variance, regression, and correlation. 3. Specify the variable. Specify the variables you want to analyze and any additional option for the test. This may include specifying the level of significance, the type of test, one-tailed or two-tailed, and any covariates of factors to include in the analysis. 4. Run the analysis. 4 says run the analysis and review the output, which includes summary statistics, effect sizes, and p-value. 5. Interpret the results. Interpret the results and draw conclusions about the population based on the sample data.